You were welcome. All right. So we're starting off with y prime equals to 2x squared. Now don't blurt anything out, but see if you can think of what would potentially have this as a derivative. What would potentially have this, so kind of work backwards in your mind how you would come up with the function that you could take the derivative and get this. All right, I heard someone say there's going to be an x cubed in it. Okay. It's going to have to be a fraction, okay. So you're saying 2/3? All right, let's see if that works. If we have 2/3 plus what? Plus 64? Okay. Let's see. Will this work? What is 3 times 2/3? 2. So it'd be 2x squared plus 0. Regina, this one's dedicated to you. Because you don't like negatives and you don't like fractions. But what's the derivative of that? It's still 2x squared, right? Okay. Tony doesn't like radicals. Or decimals. Notice I put my radical extender on there. But all of these functions have this as the derivative. Let me give y'all another one to try. That's beautiful. Approximately. Ooh. What did I just do to y'all? 1/6 x to the 6?
Plus 50 trillion.
Plus 50 trillion. That's the number we used last period.
Did Daniel Conway shout it?
Yes.
Yes. I just didn't know really.
That's scary how y'all had the same number there, and how you knew it was him.
I could hear it. It's either him or Tucker, so definitely Tucker probably.
All right.
Probably right. Probably sure.
So, does that work? If we multiply 6 times 1/6, we get 1. So it would be x to the 5th. Are we good? All right. And then what's the derivative of 50 trillion?
0.
All right. 5? No. Thanks for offering. Can I erase this?
Yes.
Oh, snaps. It's not a number.
Y equals x to the n. Do not blurt anything out here.
It's whatever you want to say.
Huh? Y prime. It's y prime, yeah.
It's whatever you like.
Y prime equals x to the n. Again, don't blurt anything out. Does anyone feel like they have a
1 over n times x to the power n plus 1.
All right, 1 over n
Times x.
times x
Power of n plus 1.
to the power of n plus 1. Alright, let's see. N plus 1 times 1. That'd be n plus 1 over n.
N plus 1 on the bottom.
Okay, yeah, so let's make it n plus 1 on the bottom and see what happens here. If we take n plus 1, multiply it by 1 over n plus 1, what do we get? Starts with a W. 1. So it's 1, and then it's x to the n plus 1 minus 1 is n. So we get x to the nth there. And that is y. But now, let's just say that it's going to be plus some constant there. Yeah. This would be the family of functions that has this as the exclusive derivative. It's good stuff. Now, why did we work this problem? Because I told you to, that's correct. But what would be the benefit of working this problem? It's a formula, yeah. So now when I have some exponent, I don't have to sit here and play through my mind, okay, what's happening here? I can just say, okay, we've got y prime is going to equal to x to the 10th. So I know that y would be 1/11 x to the 11th. Notice how I made my second one cursive. Alright, so it's 1/11 x to the